All right, so in this video, we are going to look at how you can define custom functions in Python. All right, so what's the use case for functions? So as you've kind of seen in some previous videos in this playlist, I have imported a library like random, and I was using that random int function from that. We've also seen built into Python, we've got like the print function, we've got the sum, the min, the max. So in general, whenever there is a particular operation or set of computations that you anticipate that you are going to perform repeatedly in your code, you might want to define a function. So functions are meant to be just kind of reusable bits of code. And the benefit of defining it in a function is that if you end up changing the definition, so if you change the way that you're doing those computations, all you need to go do is modify that function definition one time, and it will essentially take effect throughout the code wherever you're using it. So functions are kind of a critical piece for reusability. So whenever, again, there's a set of computations that you're doing over and over again in a piece of code, instead of having that same snippet of code kind of copy and pasted throughout, you would rather define a function and then just reuse that function call. That way, if you need to make a change, you can just make that change in the function definition and be done with it. All right, so let's look at how we define and kind of the basic structure of a function in Python. So whenever we're going to define a function, what we need to start off with is the def keyword. So you see if I do def, we get that green bold text, which is indicating to us that that is kind of a recognized keyword with Python. So def is saying this is going to be the definition for a function, and then you would want to give it a meaningful name. So I'm going to write a simple function here that takes two lists, and then it's going to do an element-wise sum of those two lists. So it's essentially going to be assuming that we're going to be providing a list of numeric values, and then I'm going to create a list that contains the sum of the values in those two lists that are going to be provided in an element-wise fashion. All right, and given that, what I'm going to do is I'm going to name the function sum2list. All right, so that's a very meaningful name given the context. All right, so we've got our def. This is telling Python, hey, we're defining a function here. We would give it a name, and then we do open close parentheses to indicate that we can pass in arguments to our function. All right, now you can make functions with no arguments. We will see that later on in this video, but a lot of times we want to pass things to this function so that it can use it for its computation. So we've got our name, and we can't have any spaces in the name, so I'm using those underscores in places of spaces between those sum2 lists. All right, and let's say that we're going to pass it two arguments. So we're going to pass list1 and we're going to pass list2. I like to, again, wherever possible, use meaningful names. So this is visually kind of indicating that this function is expecting to list objects. And very quickly, I'm going to show you some new things that have been introduced in recent versions of Python to make this even more explicit and to provide some interesting utilities to you as you're developing your code in JupyterLab or other types of editors. All right, so we've defined our functions, gave it a name. We've told it that it will expect two arguments, and then we can go on and we can define our function definition. So this is where we define the computations that are going to be done for our function. And notice that, white space is of course important in Python, so it's nesting this underneath that def. So anything that's nested under this is going to be a part of that function's definition, and we can go from there. So I'm going to make an object called summed_list, and then I'll go for item 1, item 2, and we're going to assume that these two items, since we're wanting to sum them up in an element-wise fashion, we're going to assume they're of the same length. So I'm going to be using zip, and I'll go list1, list2, so I'm just zipping those elements together. And if you're a little bit confused on what zip does, you can look back in this playlist. There's a video that goes over zip and enumerate. All right, so we're getting those two items, and then what I'm going to do is for sum list, I'm going to append the sum of item 1 and item 2. So item 1 plus item 2. All right, so that is our function definition. This is kind of defining the computations that are going to be done in our function using those two arguments, and they need to match. So if I'm passing in list 1 and list 2, they need to be referenced within our function call or within the code that's defining what this function is going to do as the same names as those arguments. And one thing I want to make clear is these names do not have to match the names in your Python code. They just need to be consistent within the function definition. And I'll show you an example of that. All right. So right now we're passing into list, we're doing some computation, but we want to return, we want to give back to the user that called this function some value potentially. So in this case, we want to return that summed list. All right, so this is a complete function. So we've got our name, we're passing in our arguments, we define the computation that is going to be going on, and this is just a fairly simple loop using that zip to essentially zip together the various elements of list 1 and list 2, and then we're returning that summed list. All right, so now if I were to define two lists, so my list 1, and let's say that that's going to be 1, 2, 3, 4, 5, and then my list 2, and let's say that that's going to be 4, 2, 4, 2, 4. All right, so I've got two lists, and now I can use my function, and I can say it expects two lists, and I can actually, if I'm holding down shift and then hit tab, I can see the signature sum to list. It takes list 1 and list 2. So I can provide my list 1 as the first list, my list 2 as the second list, and now it returns those sums. So we can see 1, 4 equals 5, 2 and 2 equals 4, 3 and 4 equals 7, 6, and then 9. So we've built a working function that we can reuse throughout our code anytime that we've got two lists of equal length that we want to sum together. All right, now I'm going to show you a few additional things. So this is a working function. This will work, but there's a few ways that we can improve this for readability's sake. Even though we did do a good job, we've named the function meaningfully, so we're summing two lists, and we've named the arguments, so it's list 1 and list 2. So we've already gone a long way to try to make this function where it's very easy for users that might not be familiar, they might not have written the function, or they might be interacting with this code base for the first time, to understand what's going on and what is expected of this function. But we can do a lot more. All right, so the first thing, if you notice when I've got this function here, when I'm calling it, if I get inside that first parenthesis, hold down shift and hit tab, all right, we see the signature. All right, so we see the function signature here. It's taking two lists, and then we've got this docstring object, and it says, hey, there's no docstring. All right, now let's contrast what we just saw right there with something like Python's print function. So if I do print, open parenthesis, hold down shift and hit tab, we get a lot more information, right? So we see, okay, well, we've got print, we've got, a lot of different things. So in ours, when we did list 1, list 2, if I were to go back, right, we just see it's list 1, list 2. Right here, they've got some equals. We'll talk about what that is in a minute and what that's kind of indicating. But notice right here in the docstring, we've got a lot more information. So it prints the values to a stream or to system standard out by default. And then we've got some information like sep. This parameter right here is a string inserted between values and defaults to a space, or end, a string. So we can provide some more information. So how did they do that, right? Why can't we do that? Well, it turns out that we can, right? So if once we define a function, right in your function definition, so your first line, if you start that with 3 single quotes and end it with 3 single quotes, or you could do 3 double quotes, either way will work. It's going to be the same. And I'll just show you that here with the 3 double quotes. We can start typing, and we can provide some additional information that will be displayed as the docstring to users when they call our function. So right now I'm just going to restart clear all outputs just to let you know that nothing is in there, and I'm going to update the definition of my function now to include a little bit more information. So I'm going to say this function returns the element-wise sum of two lists, right? And we can even put we can put really whatever we want here. So we can put some assumptions, right? Okay, so it's going to put a few spaces right there. Let's see, we assume lists are of equal length. And we assume lists only contain numeric types. Okay, now I'm going to run this. We see that our function still behaves as it did previously, but now if I get inside that parenthesis, hold down Shift and hit Tab, now we can see we've got a lot more information, right? So I can see that I've misspelled element-wise. Let me correct that, and I'll redefine the function, right? So when I just run it again, that is actually getting that redefinition. All right, so it's the element-wise sum of two lists, and then we've got our assumptions here. So now we're able to provide additional information for our users, right? And we could even put an example in there if we wanted to, right? All within this docstring. And again, I'm just going to restart and clear all outputs just to show you there's no difference if I were to do single quotes. Right, now when I go to sum to list, we can see here that we've got that same information. So all of a sudden we're starting to get, this is a lot more helpful, right? We're telling our assumptions, and again, just trying to make it as easy as possible on the user and future you when you use your function. All right, now I'm also going to encourage you whenever you're using functions. So in recent versions of Python, one thing that we've seen throughout this Python fundamentals, and I kind of talked about it earlier when we were talking about variables at the very beginning of this playlist, was the fact that Python is a dynamically typed language. Right, so what that meant was if I'm making a variable, I don't have to declare that this variable is supposed to be an integer or a string or a float when I'm defining it. I can just set, my var equal to 1, and Python's going to say, well, you set that equal to an integer, so the type of my var is currently an integer. All right, but when we're designing functions, a lot of times we have expectations on what those, values that should be passed are. In this case, right, so if we're looking at the sum of two list function, well, we're telling people here that we assume that we are going to get lists that only contain numeric types. So we're expecting lists that contain numeric types. And another piece of information that we don't get back from our current function definition is what it's going to give me back. Is it going to give me back an integer, right? Is it going to give me back a float? Is it giving me back a list? Is it giving me a dictionary? What's it giving me back? So let's look at how we can kind of assist with both of those cases. So again, right now in our definition, even though we can use variable names, in this case, list 1 and list 2, to kind of indicate to the user what we want or what we're expecting, still we can make this even more explicit. And what we're going to do is we are going to use this notion of type hints, or this concept of type hints, which has been introduced, I think, probably around, it's not a recent thing in Python, but they've been continually working on this kind of system within Python. And what it allows you to do when you're defining functions is to give the user hints on the type of objects that should be passed in. It's also, as we're going to see really quickly, it also, in addition to giving your user, it gives your editor. So if you're using Visual Studio Code, or if we're using Jupyter Lab here, it will give Jupyter Lab some hints about what an object is, so that when you're writing the code, it actually can do autocomplete type of things much more efficiently. And in future versions of Python, again, there is a very concerted effort right now at the time that I'm recording this, right? So we're at Python 3.12, 3.13, I think is in either an alpha or maybe even a beta release at this point. But there's a concerted effort to make Python run faster. And to do that, they need to do optimizations in kind of the core code base. And one of the optimizations they can do is if they can, better understand the types of things that you're defining in your code, they can put optimizations in place based on, well, is this a list of integers or floats? There's different things they can do here. So if we can provide Python with more information in future versions of Python, we might see some very real and significant improvements in efficiency because we took the time to do that. All right, so let's see how that would work. All right, so first off, one thing I'm going to do is I'm just going to define a few variables. So I'm going to define a variable myInt equals 1. I'm going to say myFloat equals 2.0. MyString equals hello. Oops. MyList equals a B. And then myDict is Alice. So the key is 1 and the value is Alice. All right, now one thing that I've tried to emphasize throughout these fundamental videos is it's important to know the type of the thing that you're working with. Even though Python does not strictly enforce that you have to declare your type, you need to understand what the type of things that you're working with. It's going to help you as you're kind of thinking through writing code, because if you understand the types that you're getting when you run certain operations, you'll know what you can do with those types. Well, what do I mean by that? Well, let's take this myInt object. And if I were to hit dot and hit tab, what Jupyter's going to do is it's going to show me a list here of essentially these are things that I can do on that integer, right? So I can get the numerator, I can get, denominator, I can make it go to bytes. I can express this as, an integer ratio. And those are going to be different than the things that I can do for my float. All right, so we've got as integer ratio, but this is our complete list, right? So notice that we've got from hex and conjugate. Let's go back to myInt and then do dot tab. We've got a lot of additional things that we can do to an integer that we couldn't do to a float. Now, if we go to a string, right, we get a whole different set of things, right? So now we can do capitalization, right? So because that's a string, I can do a capitalization. If I were trying to run that on myInt, that's going to give me an error because an int object has no attribute called capitalize. And similarly, we know with a list, right, it's got an append, right? It's got an extend, and then a dictionary, if I were to do that dot tab, it's got keys and items. So the object, each one of your objects is going to have different things, different methods and attributes available to it based on its type. All right, so what if your functions knew this as you were writing them? All right, I'm just going to show you this as a simple example. And this is really another thing to kind of motivate these type hints, which we're about to discuss. All right, so let's say that we're going to make a function. I'm just going to call it for now dummy function. All right, and it's going to take a single argument called arg. All right, and then it's going to do something. Okay. All right, so this looks up to this point very similar to what we've got. I'm going to go ahead and just put a return down here. This is actually a valid function definition. So if I were to just call dummy function with anything, myInt, this is going to run. All right, it's returning none. Okay, so when you put an empty return statement here, it's going to just return none. So if I were to do the type of this, right, it's returning none. And that's beside the point. What I want to show you is what we can do. We can give Python some more information. So right now, if I get down in this function and I do arg.tab, nothing, right? Because it has no idea what arg is, right? It's saying, okay, well, you're telling me you're giving an argument, but I have no clue what that argument is going to be. All right, so I'm hitting tab several times here, and that's doing nothing, okay? What if we told Python, hey, this thing should be an integer, right? Expect this thing to be an integer, all right? So let's look at what happens. So now when I do arg.tab, notice that I'm getting those things, those attributes and methods that were available when we had integers. What if I said, well, this thing's not going to be that, it's going to be a string. All right. So when I do arg tab now, there's my capitalize, right? So because I'm giving it this information, so I've got my argument and we do a colon, and I can just put a type here that's known to Python, and it can now say, okay, well, you give me some information. Here's the things that you could do with that argument. Right? You could capitalize it. You could, check if it ends with something. All right. Or if I said it's going to be a dictionary, right? So I say arg is going to be a dict. Now arg has a keys and items method. So this is really helpful, and this can give you some, real efficiency as you're developing, because now if you've got your argument, it knows it's going to be a dict. Well, now you can hit dot and tab, and you've got the methods available to you for that type. That's really handy. All right, so let's set this thing to be a string, and then let's do an arg.capitalize, okay, because that is a method on a string, right? You see it right there at the very top. Okay, let me just use their version in case I fat finger some, and then let's just print arg.capitalize. All right, so this is a function. If I pass in hello, it returns hello. Let me do it with a lowercase here. Or it's not returning, it's printing it. So here I pass in a lowercase hello, and then it does an uppercase version of that. So it capitalized that. All right. Here's what I want to get across. So you would think, okay, well, we're telling the function that, hey, we're passing in a string, and we saw here that the editor, or Jupyter Lab in the case that I'm using here, recognized it, said, hey, you told me this was going to be a string, so here's some methods that are available. Now, this is not changing Python to be essentially, statically typed. And what I mean by that is if you pass something that's not a string, Python's going to let you pass it. It's not going to fail just because you pass an argument that's not what you expected. Now, if you do something with that argument that's not allowed, it will cause an error. For example, now let's say I've got my dummy function, and what if I pass in an integer 1? All right, it's going to allow me to pass that in, but an integer does not have a capitalize attribute on it. So when I run this, it's going to fail. It says, hey, this integer has no attribute capitalize. So it let me pass the argument in, the method failed. It didn't have that method. So this is not, type hints are not going to prevent you from passing in the wrong thing, but they're hopefully giving a hint to both the user and the editor of what your intention is for that object that's being passed. And again, just to show you, I'm going to take off this capitalize. All right, so now I'm just printing the argument. Well, we're telling Python we want it to be a string, and we're going to pass in an integer, but it's still going to print it. Okay, so that's kind of the caveat. So we can provide these type hints. They will give you some advantages in the editor and also to the user, and but they will not prevent you from doing the wrong thing, even the thing that's aside from or not expected based on the type that you have specified. All right, so I'm going to take our sum2list function. I'm going to copy that, and I'm just going to bring it down here under where we've been working and paste it. All right, so let's modify this to be type to have those type hints. So what I like to do when I'm doing these functions, because once you start adding some arguments and type hints, this line, if you're trying to do it on a single line, it can kind of get a little bit much. So I like to break it across multiple lines. So right here before list 1, I'm just going to hit enter, and then I'm going to go right before list 2, hit enter. I'm going to put a comma after list 2 and hit enter again. All right, so you can actually have a trailing comma. That is okay. And then what I'm going to do is I'm going to say, okay, well, what's the type of this? Well, this needs to be a list. And I expect this to be a list. Okay, and you can actually, so in our dummy function, we weren't returning anything. We could have still made this indication. But you can actually specify what's going to be coming back. So right now, all we're doing is telling the user, this is what I expect going in. All right. You can also tell the user what to expect coming out of the function. All right. So you can do that at the very end of that last parenthesis. You can use a hyphen, and then essentially that greater than sign almost looks like an arrow tipped on its side pointing rightward. You can say, hey, you're going to get a list out of this. Okay. All right. We can even take this a step further, and I like to put a little bit of spacing around this just to make it. So right now we're saying we've got a function, sum2list. The first argument is what we're calling list1, and it's expected to be a list. List2, it's going to be a list, and then it's going to return a list. We can even go further than this because a list can be somewhat generic, right? We've already seen that list can have multiple things in them. You can have strings, you can have functions, you can have integers, you can have floats. But specifically based on our assumptions here, right, we said, hey, we're assuming the list only contains numeric types. And we can make that very clear by putting braces at the end. And I can say, well, this thing needs to be integers or floats. All right. So this is the syntax. So I'm saying a list of integers or floats. Now, again, I'm using Python 3.12, I think 3.12.3 at the current moment. We can check that. Let's check that real quick. So I'm going to do Python version. Yeah, so I'm on 3.12.3, and I think the ability to do this or using that pipe character on the standard types was recently released. So I think this is a 3.12 feature. So if you're running this on an older version of Python, this syntax may not work. And in fact, you might not even be able to just write lists. So again, this typing system is under a lot of evolution. And they actually have a library called Typing in the Standard Library, and that's how they first started going about that. And you had to import a list type and use. But I think in Python 3.11, it might have been even 3.10 and onward, you're able to do this. But I know Python 3.11 and definitely 3.12, you can specify just that list type. All right, so now I'm going to say that here. All right, and now we're giving the user and the editor a lot of information. So we're saying, hey, you should be, you're passing in a list1, and that's expected to be a list of integer or floating point values. List2 should be the same, and it's going to return a list. And again, we can put that that's going to be integer or floating point values. All right, let's run that, make sure we don't have any errors. And now let's call R. I'm going to pull my two lists down here just to get it all together. And then I'm going to do my sum2list function. All right, let's look at that docstring. Let's make sure I've ran that. So now let's look at that docstring. Now we got a lot of additional information, right? So we still got our docstring here. We could even take this assumption out. We assume lists only contain numeric types. Why? Because we're telling them now in the definition, list1 should be a list of integers or floats. List2 should be a list of integers or floats. So we're being extremely explicit in the definition. So again, helping the editor, helping the user really kind of understand what your intention was. And then if they, pass data that is not as you intended, then it's on them, right? But one thing, of course, this does bring with it a burden of kind of maintenance, right? So if you define this function, but then you go back sometime down the road and you change the function, the computations and the expectations, you need to make sure that your type hints match the current version of the function, because you could run into a situation where your type hints in your documentation doesn't match actually what's going on in the function, and then that could be a really confusing situation for users, to say the least. All right, so at this point we have looked at how to define a function. We've talked a little bit about type hints and the benefits that they can offer you, and I would encourage you, when at all possible, to do this. There are going to be some cases where it might not be readily evident how you need to type things. So right now we're just using basically Python, just the standard built-in types and whatnot. We're not using external libraries. It can be a little more tricky when you're using third-party packages because they might define certain objects. And how do I tell somebody that it's going to be a pandas data frame type or some other type that's defined in another library. It's definitely possible. It's not that hard. And in other playlists, like when I'm doing pandas and polars, I am going to try to be really diligent to make sure that I demonstrate defining a function with those types so that you see what that looks like. But there can be situations, so I'm not going to say that there's, you've got to always do this. You should always be able to do type annotations or type hints, but whenever possible, I would encourage you to do so. All right, so let's look at another series of examples here. So I want to show you a little bit. So up to this point are 2 arguments we passed in. Let's look at a more complicated example of a function. All right, so this is one thing that I would do a lot. If you've watched other videos in this playlist, you know that I like to generate random numbers. So I'm going to make a function that will generate a list of random integers. All right, so we're going to have that function. I'm going to give it a few arguments. So I'm going to have a size. All right. And I'm going to say that this needs to be an integer. And then I'm going to have a low. That's going to be an integer. And I'm going to use now a new operator here that we haven't seen when we're defining functions, that equal sign. And I'm going to say that's going to be 0. And then I'm going to say high should be an int equal to 10. And then I'm going to do a random seed. And that should be an int. And by default, I'm going to make that equal to 42. All right. And it should, based on the way that I've named this, it's going to return a list. All right. So this is going to be my function definition. Now let's talk through a few things. So first off, we notice that size, when I defined it here, so I've got my type hints, but I don't have that equal sign. When I do low, I'm saying, well, that should be an int equal to 0. So the difference between these two, and we've already seen this, we just really haven't talked about it, is that these are required and non-required arguments. All right, so just to give an example, when we do the print statement, right, or the print function, I should say, right, we can pass in arguments, but then notice this sep argument, it has that equals in it. And what that is saying, well, if you don't provide me a value for sep, I'm just going to use this single space. If you don't provide a value for end, I'm going to use this \n, which is the end of line character. So these are default arguments. So the user can specify custom values, but if they do nothing, that's going to be the argument that's used. All right. So what we can do then, so in our case, we've got one required argument, which is size. You have to provide a value for size. And then optionally, you can provide values for low, high, and random seed. And if you don't, low is going to be set to 0, high is going to be set to 10, random seed is going to be set to 42. Right? And you can pick and choose, right? If you just want to change the high, you can just specify, well, the high value is going to be something other than 10. All right, so let's build out our function. So what I'm going to do is I'm going to import the random library. And then I'm going to set a random seed equal to whatever the value is for the argument that we're passing in for the seed. All right. And then I'm going to generate a list of random integers. And I'm just going to use a list comprehension. So I'll do random.randint. And it takes arguments A and B for low and high. So I'm going to pass it low, high. All right, so that's going to generate one random integer, and I want to do that for I in range size. All right, so I'm using all of my arguments. My size is here, low and high is here, and then there's our random seed. And then what we want to do is we want to return our random integers. All right, so here's our function definition. Let's just put a docstring for good sake. All right. This function generates a list of random integers. The list will contain size values. All right, we could put more information there if we wanted to. But now let's look at our docstring. All right, so we've got some information right here, and we've got our type hints. So the user should be able to look at this and say, hey, I've never used this before, but I kind of understand what's going on. Right, so returning to me a list, takes a random seed, low, high, and size. All right, so let's look at how we can call this function. So if I want to generate 10 random integers, right, I can just call it with 10 here, and it's generating 10. So what it's doing, if I've got multiple arguments and I just pass it one thing, it's saying, well, I'm interpreting that you want that 10 to take the value for the first argument. So it's using 10 for size. Okay, now notice right here that we get values going from 0 all the way up to 10 because that's what our low and high values are. Okay, what if I passed in a second argument, right, 1? So I'm basically saying instead of a low being 0, low should be equal to 1, or that's how Python is going to interpret it because I'm not giving it any keyword information, and that's the second thing that I've passed in. So the best thing that Python knows to do, if we're not providing it additional information, is to say, well, take the first argument and pop that into size. Take the second argument and pop that into low. Okay, so we should see this 0 go away right here. And in fact, we do. Right, so that's working. And if I make this, 100, it's going to give me an error because it says, hey, you're trying to generate, you've got the low value set to 100, but the high value set to 10, so that won't work. So in this case, we have to have it no greater. And we could put some checks in our function to make sure that that doesn't happen. All right. Now, this is good. So what if we want to do a complete function call? We could say generate values from 6. They can be as low as 6 and as high as 20. And let's set a random seed of 0. So this will work. Now, the problem with this is that, again, if you're going back, again, functions are something that you're going to reuse over and over. So you might have this definition of this function somewhere at the beginning of your file, or you could even have it in another file and just import the function so you can actually see the definition. And then the problem is if you're calling this function a lot and you're trying to go back and debug your code and figure out what's going on, if all you saw was this line right here, you'd have a lot of confusion because it'd be like, okay, well, what is 10? What is 6? What's 20? What are those things actually doing? So what I would recommend whenever possible, right, and we're going to talk about in a second when it might not be possible, provide keywords, right? That just is really helpful. It's more code. It might even take lines because I like to break keyword arguments over lines. But at the end of the day, it's going to be more readable, more, easier to interpret. And again, you always hear me talk about readability and interpretability with respect to not just other people that might use your code, but also you got to realize you're going to be a future consumer of your code. Again, you're going to write code, it's going to run. 6 months, a year, 3 months, whatever it is down the road, something goes wrong and you've got to go look at your code again. And instead of, spending hours going back and trying to figure out, oh, what was I thinking when I did this? What was I doing here? You want your code to be where future you can just look at it and say, okay, I understand. And one way that we can do that is we can provide some information, even though we don't have to. So we see that this works, right? So we're getting this back and that's operating correctly. But what we can do is we can say, well, size equals 10, low equals 6, high equals 20, and random seed equals 0. And one thing that you should have noticed right there, or you might have noticed, is when I'm putting in these arguments, if I'm inside the function, as long as I start, like I'm going to type RA and hit tab completion works. So you don't have to actually type the full argument for each, but it does have to match your definition, right? So now we run this and we get those values, right? So when we're running that every time, we're getting consistent values. And this is much more easy for you to kind of come back and interpret years down the road, right? All right, so this works. Now, I did mention briefly that there could be cases where that does not work, all right? So let me show you that. And this is a recent addition. So this is just giving Python developers a little bit more flexibility over how they define functions to kind of make sure that users are consuming their functions in the intended way. And in particular, what they have done is they have added this notion of keyword and positional only arguments. All right. So we see that this works right here. And instead of actually copying it down and doing it, I'm just going to work off this same function definition. So let me restart clear outputs. And then I'm going to go top to bottom right to where we are. All right. So that was our sum to list. All right, so here's our list of random integers. We just ran that, and that worked, right? So I provided a size, low, high, random seed. Everything worked fine. Now, watch what happens if I put a forward slash and a comma right between size and low. All right, now we just ran this function. I'm going to hit Shift Enter. All of a sudden, the function doesn't run. All right, and if we look at the error that it's returning, it says, well, there's a type error. It says, hey, this function you defined got some positional only arguments passed as keyword arguments. Okay. And in particular, it's saying size. It's saying, hey, you passed a keyword argument called size, but you can't do that. Well, when I take this away, it works fine. Right. So what Python has recently introduced in their syntax is the ability to specify when you're defining a function that certain arguments have to be positional. Okay, so it has to be positional. So anything before, so when you're writing this function definition, I've got size here, and I can put more arguments. But then when I put that backslash, this is, or that forward slash, it's saying, hey, anything before this has to be passed by position. All right, so it's enforcing that, okay, users are going to pass these values in strict positions. All right, so how would we now call this function? It's saying I can't call size with a keyword. It's only interpreting the argument for size, what's being passed into that, based on its position. And in particular, it's the first thing. It's going to be the argument in the first position. So now, run that. Now the function runs. All right, so size is now a positional only argument. Okay. Now, similarly, let's say that we wanted, low and high. Could be, let's say, so currently I can just pass in 10 and I can still pass in low and high as positional arguments as well. It's saying, well, this is the second thing, so that's got to be low and that's going to be high. I could also pass in random seed. All right, so all that works. It's fine. There could be, in addition to positional only, function and code maintainers can specify that if you're going to call certain arguments, you have to use the keyword. So they can force you to do that now. All right, so how would they do that? So let's say I want to make random seed where you have to tell me that you're using the random seed. What you can do is you can do the asterisk. All right, so the way that this function definition is set up, so right now size is positional only. You have whatever is passed as the first argument cannot have a keyword, and that's going to be interpreted as the size. For low and high, which fall between that forward slash and this asterisk, you can pass those as positional or keyword, but random seed, it has to be keyword. All right, so now when I run this fails, right? And why is it? Well, because random seed, I'm saying, hey, you got to provide the keyword. So what it is expecting me to do is do random seed. Now that works. And notice that in between, I can do low and I can do high. So that's going to be fine. I can even do this combination. Don't specify low, and it's still figuring that out. All right. So there's a few different ways that you can go about it. One thing that you can't do, and I'm just going to mention that now, is whenever you start specifying keyword arguments, and this is why they force this ordering, so it's always positional, and then everything after this is going to be keyword only, and everything in between those are going to be positional or keyword, is you can't do something like this. Let's say that I'm going to specify a value for low, and then I'm just going to put high there. That's going to give you an error. So you can't have a positional argument following a keyword argument. So once you start using keywords in your call, you need to continue that for the remainder of the arguments. All right, and again, in general, I would encourage you whenever possible, if the function, the people that have defined that function, if they allow you to specify things with keywords, just do that, because I think it's more readable, it's easier to interpret. How can you know if their function allows you to do that? Well, when you go into your function, if you hold down Shift and hit Tab, if you look at that signature, notice that in addition to your type hints, it also includes the / and the asterisk. So this is telling me, or telling the user, hey, anything size has to be position. That's position only. Low and high, they can be keyword or positional. And then random seed is going to be a keyword only argument. All right, so there's one more thing that I want to cover in this video after I drink some water. Notice that we've used this random library here. All right, and let's actually, let's not even go through the library. Notice that we use this random integers here. So we defined a thing called random integers in this function. All right, so generally when I do something like my var equals 1, right, now I can use my var because I've already defined it. So it looks like we've defined random integers when we wrote this function. Well, let's call it. It doesn't exist. So that name is not defined. So this brings me to kind of the last big point that I want to mention with functions, and that is their scope. Okay, so if you define variables within a function, their scope, or their essentially realm or universe of definition is within that function. So you can't necessarily access them outside of the function. They're not going to be defined in your overall code base. And that's desirable. So it kind of keeps things isolated within your function. All right, so this function will run, it makes random integers, and when that function exits, that object no longer exists. Okay, so we can see, even though I've got random integers right here and it's returning them, right? So that would have been random integers in that function call. If I just try to call that name outside of the code block, it doesn't work. All right, and that's kind of helpful, but there's some interesting cases, right? So let's look at a couple of those. All right, so I'm going to do a restart, clear all output, run down. All right. I'll delete those. I'm going to put a few cells right here. I'm going to work with a little bit of a gap just to keep us good and focused in. Let me make me a few additional cells. All right. So here we go. All right. So I'm going to make a function, just a dummy function. All right. So I'm going to define it as dummy function. All right. It's going to have no arguments, and it's going to have a variable called my var. And I'm going to say that that is equal to 200. And then it's just going to print. We'll use an F string, and I'm going to say in the function call, or in function, let's say dummy function. And then I'll do a my var equals. All right. And I'm just going to omit the return, so that again will just return none. So if I were to run dummy function, it prints the value of my var. And if I were to check the type of what's being returned here, I don't have a return statement, but it is returning a none type. So whenever you don't include a return, it's going to just return none. Right. So if you were to do x equals dummy function, the type of x, that's going to be defined because you've defined it here. But now if I do the type of that thing, it's none. All right. So I've got this dummy function, and we can call it, as we just saw, and it's printing this my var thing. All right, well, what if we did this? So I'm going to say my var is equal to 10, and then I'm going to copy my print statement here, and I'm going to say before function that my var is equal to whatever. I'm going to call the function, which in this case, I'm doing this purposefully. I'm using the same variable name outside of my function and within the function definition. I would generally discourage that, but this is just to make a very, very clear example. All right, and then after the function, again, I'm just going to print. I'm not going to do the assignment here. I'm going to say after function my var is equal to. So think about this. We've defined this object called my var. It's equal to 10. Then we've got a function that uses the exact same variable name, but we set it to something different. And we're going to print out that value. And then we're going to exit the function and we're going to print my var. So what's going to happen? All right. So notice my variable or my var is equal to 10 before the call. When we enter the call, my var is equal to 200. And then after, it goes back to being equal to 10. Why is that? Well, this instance of my var is defined within the local scope of the function. So this object is actually not operating in the same space as this variable. So this gets a little bit tricky, right? So the things that are, going on are happening within that function. All right, and it can get even a little bit more interesting. All right, so let's update this function now. So our dummy function. So we see that this is not working. Let me clear all of this, and let me delete everything above for now. There we go. All right, so this is a lot cleaner now. Very good. All right, so let's make it where this function actually takes in an argument now. Okay, and then I'm going to say argument, or let's make it the same. Let's make it my var. Again, I would generally not advise you to do this to match the argument signature, what you're passing in as arguments with something in code. But again, I'm trying to make a pretty explicit point here. So I'm gonna break my own rule and do this. So I'm passing in something called my var. I'm gonna set that thing equal to 200, and then I'm gonna print what it equaled. All right, now you might say, well, why is this any different? Well, previously we had just defined something within the function, right, and just printed that. So in this case, I'm actually gonna pass in the object that we've defined externally into the function, and then set it equal to 200, and then print that and see if it changes. So we've defined my var is equal to 10 out here. I'm actually going to pass that thing in, that object in, as the argument to my function, and then we'll see if it changes afterwards. And it turns out that it does not. Right? So again, let me restart the kernel. We'll make sure that everybody is sure that there's no tricks going on here. All right, so I'm passing it in. It's going to make that change in the function, but we're not returning that value and reassigning it to our variable. So that is fine. I would generally encourage you not to be doing this, though. This is not a good practice because it will bite you with certain objects. All right. What objects? Well, now let's modify our functions. I'm going to restart it again. So instead of taking in, let's assume that this thing is not going to be just a float or an integer in this case. Let's assume it's going to be a list. And now I'm going to take my list and then do a dot append 5. All right. And then within the function, I'm going to print my list. And outside the function, let's say that we've got, my list, whatever that is. I'm actually going to name it differently to show that this should bite you in any case. Let's see. So this is going to be my outer list. Okay, it's equal to 10. And so I'm going to actually make this a list. All right, so I've got this thing called my outer list. It's equal to a list of the integers 1, 2, 3, 4. We'll print it here. Then I'm going to call my dummy function. I'm going to pass it my outer list. That's going to get substituted into this my list variable. We're going to append 5. We'll print out what it is here. But what we've seen when we were doing this with integers and when we were doing this with other things, it wasn't affecting it. Right? I mean, when I called it after that function had executed, there was no change. So let's see if that happens again. So then I'm going to update this and say after the function, what is the value or what is the object my outer list? All right. So now we see that it does mutate. All right. So this is the exact same situation that we had a minute ago, right? Remember, we had passed in an integer changed the value, reassigned that integer, and then we had checked it when it was outside of the function, and it had not changed the function value. It, of course, had taken on the value we assigned to it, but once we got outside that function, nothing had changed. Well, when we have a list here, if I pass that thing in, it's actually changing that object, so it added that 5 to it. Right. So this is why I would just generally discourage you, right? You got to be really careful when you're passing things in, you know, that you're not going to mutate and alter the object unless you intend to. All right. Now, could we actually get away from this? Right. So we actually could. Right. So what we could do is something like this. Instead of saying, well, my list here, we could actually make a copy of the thing. All right, so I'm going to say my list is coming in, and I think we're going to verify this on the fly. I'm just going to say, you know what, my list is going to be a copy of it. And I think all I have to do is say, just take my list and make it a list. And this looks redundant, right? Because I'm saying, okay, well, take my list, which is already a list, and I'm wrapping it in list and saying, okay, make it a list of my list. And then I'm going to append 5. All right, so let's see what happens now. Now, I could be completely wrong, so we're going to check this, but I do believe that this makes a copy of that object. In this case, we pass in my list, we make a copy, we append to the copy, and then we're printing it. All right, so there we go, right? So this simple act right here is making a copy, so we're no longer referencing the same object on our computer's memory. Right, and that's really important. And then in later playlists, when I'm looking at pandas and other things, or you know whatever we're looking at, sometimes when you watch me code, you'll notice that I'm very conservative in functions about if I'm bringing in an object, I'll usually make a copy of it. You know, that might not be the most memory efficient thing, because in certain cases, it could be that, okay, we could, you know, just make sure that we're not overriding that object. But I tend to be really conservative and go ahead and make a copy of an object if I'm bringing it in. And I especially in cases where I'm wanting to make sure that I don't change the thing, right? Where I'm maybe just doing operations on it to figure out some type of statistics or something else. You can make a copy of that object, because that will, as long as I'm operating on the copy, I can ensure that I'm not actually going to mutate the real object if that's not my intention. But regardless, that shows you kind of the caveats of passing things in. And this was somewhat of a lengthy video. I hope this gave you a good overview of functions. So we looked at pretty much everything from basic definitions, how we could do type hints, and how that helps the users and the editor as well. You know, we looked at how we can do default arguments, how we could do positional or keyword only arguments and that type of syntax. And then here we were talking about scope. So hopefully this has given you a good overview of Python functions, which are extremely useful. And again, if you're going to be repeating blocks of code, you definitely want to do functions. That's not just true for Python. That's any language. Functions are, you're able to define functions in pretty much every language out there. So get used to them, use them. Make sure that you document them well for your potential users and for future you. And with that, that will conclude this video.